Okay, so on to question 10 on exercise 27.1, page 304 of the textbook. So we have a straight piece of wire of 2.5 amps is placed at an angle of 60 degrees. Okay, so my theta is going to be 60 degrees to a magnetic field of magnetic flux density 3 Tesla. The wire is of length 50 centimeters, so that's 0.5 meters. Resolve the magnetic flux density into components parallel and perpendicular to the wire. Which component causes the force on the wire? What is the magnitude of the force? In what direction does it act? Okay, so I'm going to draw this one differently to the way I did question 9. Imagine I've got my wire here, okay? And that is I is coming out of that, okay? Now, actually, I'm going to... Alright, so what they're saying is that my magnetic field is at an angle of 60 degrees to the wire. I know it looks like the same as question 9. Sorry for the dog groaning at you there. Alright, so there is my B. And it's making an angle of 60 degrees with the wire, okay? So what they want us to do is resolve the magnetic field into parallel and perpendicular components. So what they're saying is that I have a line here that essentially is of length 3. Okay, so that's 3 Teslas, right? But the size of it is 3. That makes things easier. So because the wire is going like at this angle up here, I need to figure out how much of that 3 Tesla is going up and how much of it is going out that way. So we're breaking it up into a right angle triangle. Okay, I've just moved this arrow from here over to here because that's how you resolve vectors. Okay, so I know that this one here is my theta. That is 60 degrees there. Okay, so this line up here, the parallel vector, I'm going to call that again B parallel symbol, and then this one's B perpendicular symbol. Okay, so just based on this being a 3 and this being 60 degrees here-ish, it looks like the perpendicular vector is going to be longer than the parallel vector, but we can work it out. So in terms of this theta, this is the adjacent side, okay? And to figure out that, I know that the cos of theta, can you still see that? Yeah, the cos of theta is the adjacent side over the hypotenuse. Okay, so that means to calculate the actual adjacent side, I do hypotenuse multiplied by cos of theta. Similarly, the opposite side, which is this one here, B perpendicular, is the hypotenuse times the sine of theta, using the same argument as up here. Sine theta is opposite over hypotenuse. So that will be this component here of this triangle, which is the same as the one I've mapped out down here. So it would be Sokoto, silly old Harry, whatever you want. Sine is opposite over hypotenuse. So